Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to take a look at a word problem that a couple of students had. They sent it in, and here we are. So this is an Algebra 2 problem. We're looking kind of at chapter 2 in this Big Ideas book. And it's mostly on quadratics and how to write these equations, what the equations mean, different types of intercept form, vertex form, things like that. So in this particular problem, what we're looking at, and we'll just go ahead and dive deep, it says a basketball is thrown up in the air towards the hoop. So this tells me, this piece of information tells me right here that I know my graph will look, whoops, did not want yellow. I know that my graph is going to look kind of like this, where I'm standing here, here's the ball, and I'm throwing it up, and eventually it'll hit the ground. Okay, so right away, I know this is a negative x squared graph. It may be a negative 1, 2, 3 x squared graph, but I know it's definitely negative x squared. I know that at some point I'm going to have my axis of symmetry where my vertex is going to be, and then I'm going to have this kind of like rising action and falling action before and after the vertex. So then they tell me that the table shows the heights, h is in feet, of the basketball after t seconds. Write a function to represent the table below. So one of the things that I noticed when I was looking at this problem to think about how would it be best to solve is that I can tell right in here, that's my vertex. And the way that I can tell that that's my vertex is because I have two numbers on either side of this number, of this set of numbers, of this vertex, that are exactly the same. So if they were both 10 and 10, if they were both 12 and 12, if they were both even like 1/2 and 1/2, regardless of what it is, that's exactly where my vertex is. My vertex is in the center of the table. So I can go in and I can say, okay, well, I've got vertex form. Vertex form is y equals a, whoops, not h, x minus k, minus h, sorry, squared, plus k. So I can right away replace my h and my k with 2 and 13. So I'm going to go in, I'm going to say y equals a x minus 2 squared plus 13. The only thing is, normally my quadratic equations, they don't give me any other variable other than x and y. And also, since we said that we know our x squared is going to be negative, and this is not a negative number, we kind of have to go in and say, hey, what's the problem? So we need not to have 3 variables, step 1, and step 2, based on logic, we need this guy to be negative. So in order to help us figure that out, what I am going to do is I'm going to take this 1 and 11 and replace the x and the y with 1 and 11. So, for example, in here, I'm going to have 11 equals a, and then 1 minus 2 squared plus 13. So now I've only got one variable, and I can go ahead and solve using order of operations, PEMDAS, right? So I'm going to end up with 11 equals a, this will be negative 1 squared plus 13. So 11 equals 1a plus 13. I'm going to subtract 13 from both sides and get negative 2 equals, well, 1a or a. So now we fall in line with that same, hey, x squared has to be a negative number. So then I'm going to go back into this original equation that I've had, and I'm going to say y equals negative 2 x minus 2 squared plus 13. And this is my equation of this line, or of this quadratic function. Now, they did say write a function, and normally I like to just leave y and x in the beginning, just to make my life easier so that I don't have lots of extra numbers, But if your teacher is a little bit particular, definitely go ahead and replace the y with f of x, and the rest will follow as is. So then you're going to have this as your function. All right, until the next time, I'll see you later. Bye.